Today we're looking at dividing polynomials by using both long division and synthetic division. So these are two different techniques we're looking at. And let's start with long division. So the way this problem is set up is you have your polynomial here, and with that semicolon, that's just separating the problem that you are working with from the divisor. So this is what we call our divisor right there. And so we're going to place that divisor here on the far left-hand side, and then this long division bracket. So this is not the square root, okay? Just the long division bracket, and the polynomial will go inside that. What we're doing is we're creating a column for every descending power. What that means is if I am starting off with an x squared, then I need to have an x squared. I need to have an x to the first column, which we have a term with x to the first, so of course that exists. And then here we have a column with no x at all. That's our constant term. So if it helps, you can think of these little divisions creating the three columns. We're going to ask ourselves a series of questions. We need to figure out, what do I use to multiply with this x to get this x squared? So we're just looking at the first term of each section. We're not looking at the 3. We're not looking at the 10x or the 21 just yet. We're just looking at the very first term of each section. So something times x has to get me an answer of x squared. So we know that's an x. And we'll put that in the matching column of x to the first power. Now we'll distribute that x to the divisor. So think of this like a binomial wrapped in parentheses. X times x is x squared, and that goes here in the column matching the x squares. X times 3 is 3x, that goes here in this column matching x to the first power. Then we subtract each of those columns. So x squared minus x squared cancels out. 10x minus 3x is 7x. Then we bring down the next value, which is our positive 21. So again, we ask ourselves, what do I need to multiply with this x to get me a positive 7x? So again, we're just looking at the first term of each section. We're ignoring the 3, we're ignoring the 21. So I know I need a 7, right? Because 7 times x will give me the 7x. We put that here in the column with the constant terms. 7 times x is 7x, and 7 times 3 is 21. And again, we subtract each column. So 7x minus 7x cancels out. 21 minus 21 cancels out. That means there's no remainder. That means this divides evenly. So you can think of this like factoring. This one is able to be factored because there's no remainder left over. And if you guess and check your factor pairs, you would find out that it factors into x plus 3 times x plus 7. Right? If you multiplied those back together again, it would turn into the original problem. So there's your answer of x plus 7. Here's problem number 2. Here's my divisor of y plus 1, so we'll set that up on the far left-hand side. Here's the division bracket, so 4y squared plus 19y and plus 21. Again, if it helps, you can separate them, those columns, to keep it organized. We take a look at the first term of each section. We need something times the y to get me the 4y squared. So we need a coefficient of 4. We also need a y. So positive 4y will go here in the column matching y to the first power. Then we distribute to the divisor. So 4y times y is 4y squared. And then 4y times 1 is just positive 4y. Now we'll subtract. So the 4y squareds cancel out. Here we have a 19y minus 4y. So that'll give us a difference of positive 15y. And then we bring down the next term, which again is 21. Something times y must give me the 15y. Again, so we're looking at just the first pair, and we'll need a 15. So positive 15 is what we want. And now let's distribute to the divisor. So 15 times y is 15y. 15 times 1 is 15, right? Let's subtract. So the 15y's cancel out. Here you have a 21 minus 15. That gives you a 6. So notice now we have a remainder. We did not in the previous problem. It divided evenly because everything's subtracted out. But if it does not, and often it doesn't, we have a remainder of 6. So we will format the answer with that remainder here. So the answer is 4y plus 15 plus, and then you put your remainder over the original divisor of y plus 1. So that's your answer. It looks strange, but if you were to multiply this with the y plus 1, it would turn back into that original polynomial. Just like in number 1, if you multiply x plus 7 times x plus 3, you would get that original problem. So we're not going to do that multiplication step, but that's what would happen. Let's jump over to number 4. This one is a bit more of a challenge because now we have two variables. We have both x and y represented. But here's the divisor, x minus y. I need a long division bracket for this one. We have our x squared. We have a term of plus xy, and then we have a term of minus 3y squared. Now again, we need a column for every descending power of x. And we've seen those in the previous examples where it had a power of 2, a power of 1, and then no power at all. Here in number 4, you see we have an x squared, but where is my term of x to the power of 1? This doesn't count because this is x to the 1 times y to the 1. We need a column of just x without the y as well. So we need to create a placeholder. So create another column with a coefficient of 0 because it doesn't actually exist in the original problem here. But this will be my placeholder for a column so that I can have x to the power of 1. So there's my x squared column. There's my column of x to the power of 1. Same with the y's. I have a column for y squared, but where's the column for y to the power of 1? It doesn't exist, so we have to create a placeholder for that, like so. So that's why we have a much bigger division bracket in this problem. Okay, again, you're looking at just the first terms of each section. Something times x must multiply to x squared. So we know that'll be an x. We put that here in the column matching x to the power of 1. Now distribute to the divisor. So x times x is x squared. That goes in the column of x squareds. X times a negative y is a negative xy. That goes here in the column of xy. So notice that's a negative sign because we multiplied positive times a negative. You have to watch out here for the subtraction step. X squared minus x squared cancels out. That's no problem. But watch out here. You have an xy, but then you have to subtract a negative xy. So you're subtracting a negative. That means it's turning into adding a positive. So you have a positive adding a positive. That totals to a positive 2xy. Bring down the next term. We have a minus 3y squared. And look at the first term of each section. Something times x must multiply to a positive 2xy. We need a 2, we need a y, so a positive 2y. That'll go here in this column. Let's distribute that to the divisor. So 2y times x is a positive 2xy. And then 2y times a negative y is a negative 2y squared. So when we subtract these, they will cancel out. I'm running out of room there, but they drop out to 0. Again, watch out here in this middle column because we're subtracting a negative 2y. So it's a negative 3y squared minus a negative 2y squared. That turns into adding a positive 2y squared. So it's a negative 3 plus 2. That results in a negative 1y squared. Now there's nothing to bring down because you're really just bringing down a 0, and here you're bringing down a 0. So that means we're done. That's our remainder. So the answer is x plus 2y plus, here's my remainder of negative y squared over the original divisor of x minus y. So we're going to look at this concept again in our next example. More specifically, I want you to try number 6. Okay, so pause the video, work this one out, see if you can set it up correctly. Work out all of the subtraction in each column, and then turn the video back on when you're ready to check your answer. All right, so here's the answer. Are you ready? I'm going to reveal it. Here it is. You should have that x squared on your first term, negative 8x on the second, positive 16, and then finally your remainder is that minus 31. So there's all of the work you can take a look at. Again, be very careful when you're subtracting. For example, let's look at this section right here. We have an x squared times an x, so there's your x cubed. X squared times 2 is a positive 2x squared, but when we subtract it, it's a negative 6 minus 2. That creates a greater negative, right? So it's a negative 8x squared. So on the next step, we need something times x to get us the negative 8x squared. So that's why we have a negative 8 here. Negative 8x times x is a negative 8x squared, and then negative 8x times positive 2 is a negative 16. So again, be careful. We're subtracting a negative 16. So 0 minus a negative is adding a positive. So that's why you have a positive 16x right there. So just be very careful of your signs. All right, now we'll take a look at a couple with the synthetic division. Here we go. Going to problem number 8. Now it's formatted a little bit differently where you have the polynomial in grouping symbols and there's your division symbol, but it could have been set up like what you saw up here with the semicolon separating the polynomial from the divisor. It doesn't really matter which one we use, it's the same concept. We're still dividing. This is your divisor again, right? But with synthetic division, we're not using the variables, we're just using the coefficients and the constant terms. So the very first step is to find the divisor, and to do that, we're going to take that divisor as it is given to us, set it equal to 0, and then solve for the variable. So in this case, just add 6 to both sides. So obviously, it's just positive 6. That's our divisor. So just as another example, let's say you had something crazy like a divisor of 2a minus 6. If that was your divisor, then notice a couple of steps later, you end up with 3. So in the synthetic division problem, if that was your divisor of 2a minus 6, you would actually be using a value of 3 in the process. But for this problem number 8, it's just a one-step problem, and we end up with positive 6. So what we do is we take that divisor of 6, we put it on the far left-hand side of this synthetic division bracket, and then we're going to pull the coefficients from each term. So we're using just the 2, just the minus 2, and just the 5. So there's no variables represented in this system. Now, the 2 is still representing the coefficient on an a cubed. So this first column is all about a cubed. The second column is about a squared. And guess what? We don't have a column for a to the first power, so we need to squeeze that in right here. There's my a to the first power. There's my constant term. So once again, we need a placeholder. I have a 0 as a coefficient on that a to the first power, just like we had 0 as a coefficient on our x or y, the above example. So we need a column for every descending power, a 3, 2, 1, and then the constant term. We're going to start by just writing the first coefficient of 2 on the bottom of that little bracket, and then we'll go through these 2 steps. We're going to multiply back and put the answer in the next column and then add the next column. So 2 times 6 is 12. Now add these numbers. Negative 2 plus 12 is 10. Multiply that back to the 6, we have a 60. 0 plus 60 is 60. Multiply that 60 back to 6, we get 360. And then we add the next column, 5 plus 360 is 365. So you can get some pretty big numbers here, so don't be alarmed. Now what we've done is we've actually divided out a term of a, which means that this answer is not representing a cubed anymore, it's 1 power less. This is 2a squared. This 10 is not a squared anymore, it's a to the power of 1. This 60 is not a power of a to the first, it's instead the constant term, which makes the 365 the remainder. All right, so let's reformat this a little bit neater. The answer is 2a squared plus 10a plus 60. And then with the remainder, again, you put this fraction of the remainder over the original divisor. We're back writing this answer in terms of a, so we have to have that a included in the divisor as well. So 365 over the a minus 6. All right, let's do one more together. Let's take a look at number 9. So notice I have p to the power of 5, so count every descending power. See what you have and see what's missing. I'm looking for a p to the 4th. That's missing. I have a p cubed. I have a p squared. I don't have a p to the power of 1. And then I've got my constant term. So in setting this up, we will need those placeholders. So again, here's our divisor. Subtract 2 from both sides. We're using a negative 2. So my negative 2 is on the outside of my bracket. So here's the 2 for the p to the power of 5. Then here's the column for p to the 4 with the coefficient of 0, because that's my placeholder. Then for p cubed, I need a negative 1. For p squared, there's the coefficient of negative 5. for p to the power of 1, I need another placeholder, and then finally the constant term. So that's typically how we show it. We usually don't label it like we did in the previous example, but with so many columns, it might be a good idea to label just to make sure we didn't lose track of anything. So there's p to the 5th, there's the power of 4, p cubed, p squared, p to the power of 1, and then there's the constant term. So yeah, we got everything. Bringing down the first two, we're ready to start our process. Multiply that back, we get a -4, and now add. So you have a 0 plus a -4, so same thing as subtraction. Multiply that back, you get a +8, so -1 plus 8 is 7. Next we have a -14. Again, -5 plus a -14 is even more negative, so -19. -19 times -2 is +38. Multiply that back to -2, you get a -76, and that turns into -73. So the final answer is 2p to the 4th, because it's 1 power less, because we divided out a term of a, minus 4p cubed plus 7p squared minus 19p plus 38. That's the constant term. So the 73 here, the -73 is my remainder. So minus 73 over the original divisor of p plus 2. And there's the result.